Welcome to Cascade Chemistry. This is Toxins Lesson 23. This is about precipitation reactions. You probably remember a while back we looked at some precipitation reactions when I mixed two different solutions in a test tube, and in most cases a cloudy white suspension formed in the test tube, and as time went on that suspension sunk to the bottom, and that was the precipitate. You could see the solid a while later, and the top part was a clear solution. I did another one with some copper compounds, so it made some blue precipitate of copper that sunk to the bottom. So anyway, that's what we're going to be going back to, precipitation reactions, what they are, what's happening on the molecular level. We'll start up here. Some ionic compounds like table salt are soluble in water. Soluble means that the substances dissolve. In most cases, we're talking about water, which is an aqueous solution, AQ. Precipitates are solids that form from the mixing of two aqueous solutions. The solid forms because the cation, the positive ion from one aqueous solution, is not soluble with the anion from another aqueous solution. That is, the ions find each other in solution, and they bind to each other and form a solid. The section here in green, that I've circled in green, those are everything that's soluble, and the rest of these N is not soluble. And we can see that the nitrates are always soluble, like potassium nitrate, magnesium nitrate, nickel nitrate, even mercury nitrate is soluble. And likewise, all alkali metals are soluble. So lithium chloride, sodium hydroxide. Now, rubidium isn't written down here, but rubidium is an alkali metal. So let me remind you, the alkali metals are right here on the periodic table. So they are always soluble. So what would happen if you mixed a solution of nickel nitrate and sodium hydroxide? Well, here's the nickel nitrate and the sodium hydroxide. They both start as solutions. And if we look at this cation and this anion, sodium and nitrate, they're soluble, so they won't attach to each other in solution. They'll stay separate as ions. But nickel hydroxide is not soluble. So the nickel and the hydroxide ions will bump into each other in solution. They'll stick to each other, and a crystal will form as more and more ions start accumulating. So what is this going to look like? Well, let's start by writing the solid, the nickel, Ni, and nickel is a 2 plus. I'm just doing this to remind you how to write formulas. And the hydroxide that it's going to combine with is an OH minus. And so we're going to need 2 of those hydroxides to go with 1 nickel. So NiOH2. Okay, so 2 negative 1s to go with 1 plus 2. So what's left? What's left is the sodium and the nitrate. And this is a solid here, by the way, so I need to write S. And then NaNO3 is the aqueous ions, the ions that are dissolved, that haven't formed a precipitate. One last thing we need to do here, we need to balance the equation. I see 2 nitrates here and only 1 here, so I'll put a 2 there. And that now gives me 2 sodiums, so I'll need a 2 there. And that's good because that gives me 2 hydroxides, which we have right here. Okay, so that equation is balanced, 1, 2, 1, 2. The next thing to talk about in your book is complete ionic equations. A complete ionic equation takes an equation like this, a regular equation, and it breaks all the aqueous things into ions, but not the solids, liquids or gases, because they're not ions. They're molecules or an ionic compound anyway. The ions are stuck together here. So if I take the sodium hydroxide and I break it apart, I get 2 sodiums and 2 hydroxides, and the nickel and nitrate, I get a nickel and I get 2 nitrates. And then on the product side, the ions that haven't come together, that are still aqueous ions, 2 sodiums and 2 NO3 minuses. And then the nickel hydroxide I leave as a solid precipitate. So there's the complete ionic equation showing all the ions in solution before and after, and showing any solids, liquids, or gases. So there's our complete ionic equation. The next term you're going to learn about is net ionic equations. And they tell us what's actually reacting, not just what's there in the solution, but what is reacting to form a solid, a liquid, or a gas. And so if we take what was there at the beginning, like this nitrate, and what's there at the end, that nitrate, and we cancel them, sort of like canceling in a mathematical equation, we can cancel what's there at the beginning and what's there at the end. And what we're left with is the net ionic equation. The net ionic equation being nickel 2 plus 2OH minus makes NiOH2. So this is the net ionic equation showing only the ions that come together to form a solid in this case. The ions that I crossed off up here are called spectator ions because they don't react. They're there at the beginning and they're there at the end. Let's take a look at one more here. To start with, just a sentence to just describe a net ionic equation is all solids, liquids, or gases, and any ions used to make the solids, liquids, or gases. So how about this net ionic equation? Hydrochloric acid plus sodium hydroxide makes, you remember from our last section, we were studying acids and bases, an acid plus a base makes water and salt. So there's our aqueous salt, and there's our liquid water. So to write the net ionic equation, I'll start by writing any solids, liquids, or gases. In this case, there's a liquid water, H2O liquid. And what was used to make that? What was used to make it? NH plus, AQ, and an OH minus, AQ. Sorry, that's not written real well there. So an H plus and an OH minus, AQ. And those come together to make the water. All right, so let's go on to the next page here. And this is from your book. This is some of the problems you're going to be solving. Question number 4, some problems that look just like question number 4. Circle the ionic solids that are soluble in water. Well, to do this, I'll need the table, and you have a table in your book to look at. So we have ammonium nitrate. Is it soluble in water? Well, let's see. So ammonium and nitrate, yeah, that solid will dissolve in water. It's soluble. And calcium sulfate, calcium and sulfate, yes, it's soluble in water. And how about copper carbonate? Copper, come on over to carbonate. No, it's not soluble. And silver phosphate. Let's see, silver, and we come over to phosphate. No, it's not soluble. It does not dissolve in water. And lithium carbonate. So lithium and carbonate, yeah, it's soluble, of course, because lithium is an alkali metal, and all alkali metals are soluble. All right, so the next question, I just wrote like a question, like a quiz question. So expect to see something like this on the next quiz, the quiz for this section. So, which of the following pairs of solutions will form a precipitate when mixed? If a precipitate forms, what's the correct formula for the precipitate? Okay, so will a precipitate form when we mix these two aqueous solutions? So I'm going to combine the front ion of one with the back ion of the other, and vice versa, and see if a precipitate forms. Ammonium, the cation, to go with this anion sulfate. Well, ammonium, all ammonium ions, ammonium compounds are soluble. So ammonium and sulfate, soluble. So how about calcium and hydroxide, the cation here and the anion here? This calcium is not soluble with hydroxide. So the compound is going to be calcium hydroxide, calcium, a 2+, hydroxide, a single minus. So we need 2 hydroxides to go with 1 calcium. CaOH2 then is the formula. In the next one, we have copper sulfate. Copper and sulfate is soluble, and potassium and chlorine are soluble. So will we get a precipitate? So again, I'm gonna combine the front half of one with the back half of the other, and vice versa. So how about the copper and the chloride? Copper and chloride, yes, that's soluble. How about potassium and sulfate? Yeah, all potassium ions are soluble, so no precipitate forms here. Okay, the next one, AgNO3 and NH4OH. Well, you might be noticing these silver ions are not very soluble, only with nitrate. And that's what we have here, but there's no nitrate here. So the silver and the hydroxide will come together to form a precipitate because they're not soluble together. How about the NH4 and NO3? Yeah, no, that's soluble. So the precipitate is silver hydroxide, Ag plus, and OH minus. They come together in a 1-to-1 ratio. Why don't you turn off the tape, the video, and try this one and see what you get. And then when you're finished, turn back on the video and we'll see how you did. Okay, so you probably turned the video back on. And so let's see if a precipitate forms, and if it does, what is the formula? So sodium and nitrate soluble, but zinc and phosphate are not soluble. So those two are going to form the precipitate. Zn is a 2+, and phosphate, PO4 is a 3-. So I hope I had that showing while you were watching the video. So the formula is going to be, let's see, you might remember the crossover trick. We're going to cross those two numbers over. That is Zn3PO4 2. So 3 plus 2's is a 6+, and 2 of the 3 minuses is a 6-, and so that balances. There you go, that's your formula. All right, the next set we're going to do is going to be like question number 5. So be looking at question number 5 in your book, and here we go. Name solutions you can combine that precipitate each of the compounds listed. So what 2 aqueous solutions could I mix to get cobalt chloride? So what I'm going to do is find something that cobalt is soluble with, like cobalt this is not good. Name solutions you can combine that precipitate each of the following compounds listed. This will not be a precipitate because cobalt and chloride are soluble. So that's not a good one. Let's try this next one. Sorry about that. Silver sulfate. What could we mix to form silver sulfate? Well, silver is only soluble with nitrate, so AgNO3. And what could we combine that with? Something that's soluble with sulfate, but, something that's soluble with sulfate, but the sulfate, of course, will precipitate with the silver. So let's find sulfate. So silver sulfate is not soluble, but calcium sulfate is soluble. So we could pick calcium sulfate or nickel sulfate or any of these alkali metals and sulfate. So I'll do calcium. Ca is a 2+ and sulfate a 2-, so just CaSO4. And when they come together, these two will not precipitate, but these two will give us the precipitate of Ag2SO4. Of course, you'd have to have 2 of those to go with one here. Once again, turn off the tape, and then when you turn back on your video, you can see if you got this one right. What 2 solutions could you mix together? give you a minute to hit pause. And here we go again now. So I'm going to pick something that strontium is soluble with. Strontium, an easy one to use is nitrate, but I could pick this one or sulfate. So strontium, I'll use strontium chloride. And let's see, I need a hydroxide that's soluble. Only the alkali metals here are always soluble with hydroxide. So I'll use potassium hydroxide. And so if I mix those together, the strontium and the hydroxide will come together to make the precipitate. So both those are soluble in water, aqueous solutions, that combine to form a precipitate. All right. The next one we're going to do is going to be like question number 6 in your book. So again, you'll need your chart. So let's see. What we're supposed to do here in number 6 is write an equation for the reaction between these two compounds. And so what's the reaction going to look like? Will it form a precipitate? Let's see, ammonium and chloride. I know all ammonium compounds are soluble. How about magnesium and hydroxide? Magnesium and hydroxide, yes, that does form a precipitate. So I can write the precipitate first, MgOH2, because each hydroxide is negative. And that's a solid. And what's left over would be the ammonium and the chloride. And we're going to balance the equation. So let's see, 1 magnesium, 2 chlorines here, only 1 here, so I'll put a 2 there. And that means I'm going to need 2 ammoniums over here. And that's great because that gives me 2 hydroxides to go there. So that's the balanced equation. Why don't you hit pause and try this one yourself. And when you're done, turn the video back on, and then you can see how you've done. All right. And so let's see. What will form a precipitate? Anything? How about sodium and sulfate? No, all alkali metals soluble. How about copper and phosphate? Copper and phosphate does form a precipitate. So I'll write that one second this time just to show you it can really be done either way. I'll write the solid over here. This time I'll write what's left, the ions, the spectator ions, the sodium and the sulfate, Na2, because sodium, each sodium is Na+, and each sulfate is SO4 2-, so Na2SO4, and that's AQ plus, and then the solid is our copper phosphate, Cu3PO4 2. The copper was a 2+, and the phosphate a 3-. So there we go, there's our correct formula. If you do question 7, I'm going to give you a bonus point on this assignment. It's going to show me 2 things. Even if you attempt it, it's going to show me that you tried, and we'll see how you do. So it shows me you watched the video too, because if you didn't watch the video, you wouldn't know that this was a bonus point. So please give this one a try. And what it's asking you to do is write the net ionic equation, the complete and net ionic equation for the reactions in exercise 6. So I'll do it for this one right here. So let's see. Everything is soluble here. So I'm going to have, oh, and I got to balance this equation real quick before we get started. 3 coppers, so I'll put a 3 there. And let's see. I have 1 phosphate here, and I have 2 here. So I'm going to put a 2 there. And that gives me 6 sodiums. And I have only 2 there, so I need a 3 here. That gives me 6 sodiums and 3 sulfates. So there you go. I have the balanced equation now. Let's see, just looking one more time. Yep. Okay. So I have the balanced equation. So now I have to break it apart into ions. So 2 times 3 is 6 Na plus Aq. I'm doing the complete ionic equation first, followed by 2 PO4 3 minus Aq plus 3 Cu2 plus Aq plus 3 SO4 2 minus Aq. I'm going to have to write a little smaller to get everything to fit. Produces 6 Na plus Aq plus 3 SO4 2 minus Aq. And luckily this last one is a solid. That's the precipitate. So I'm just going to write Cu3PO4 2 solid. There we go. And that's the complete ionic equation. Now to do the net ionic equation, I'm just going to cross off what's constant, the 6 NAs, and the, let's see, the 3 SO4 2 minuses, and what's left, 2 PO4 3 minus AQ plus 3 Cu2 plus Aq produces Cu3 PO4 2 solid. There you go. So we have the solid and any ions used to make it right there. There you go. So that's it for the lesson. Good luck with the homework.